The party outside has moved on to Michael Jackson. Just one of those afternoons. So we are going to now look at making our own functions. And the first bit of this is going to be a little bit like dry. And then we'll make some stuff. So when we make we've got these functions. Some of these things are built in, right? But just like with variables, we can make up our own functions and we can call them whatever we want. We can have them do whatever we want, right? And we can do that really simply by just saying function, and then we give it a name, right? So I'll make this one function called add up, right? There we go. Now I've got a function called add up, and so if I wanted to add me up, cool. Now you can see I run this, but nothing comes out in the console over here. It's because there's nothing in here. There's no event that's calling my function add up. So I need to manually add that. Since this isn't something that p5js knows about, the browser doesn't know about it, it's something that I just made up, right? I've got infinite power. I can just sort of make shit up, right? So we need to put this somewhere, right? So I'm going to put this inside of the setup. So in the setup, after we create the canvas, the first thing that will happen is I will call my function add up, right? And I can do that just like this. And you can see it looks like any other sort of command that you've called so far. Line, ellipse, random, noise. It's basically now part of the sketch. It's part of the program. You can refer to it however you want. And so if I save this and it runs in the background, we can see it prints out add me up in the console when it first starts up, right? So this is great. I know that I've created a function. I can refer to it. I can have it do something, but let's have it do something useful-ish, right? So by its name, if you haven't figured it out, I want this to add some things for us, right? So what I wanted to do is I wanted to add two values. I wanted to just add something up and return that value to me, right? So the way that we do this is we've already seen how we can pass arguments into into methods here, right? And so like 0 is the background color, right? That's an argument that we pass into the function that defines what happens whenever we call background. So we can create our own arguments for the functions that we call too. So here I've got, what I'm going to do is I'm going to say A and B. Now what it means is I've got these two things these two possible arguments that I can add, that I can put in here, right? So we can say let sum equal A plus B, right? Now if I save this, we're calling add up. It's expecting something. We aren't passing it anything, so why don't we give it something? 1 and 2, right? Now you'll see we aren't getting anything back. It's not returning anything back to our main program. That's because we're just sort of like saying add up 1, 2. There's nowhere where we're storing it. We aren't using it anywhere. That's part of the problem here. The other part is we aren't returning this back to our main program in any way, right? So we could say console.log sum, and we could see if this is actually doing something. Look, there it is. We're printing it out in the console, so we know it's adding, it's doing its thing. It's just we aren't getting it back into the program anywhere here. So you might think like, whoa, well, what if I just said let my sum equal add up, and then I said console.log my sum, right? And then we run it. Oh, look, it returns undefined. We see that the sum from inside of the, inside of add up, we can just make that a little clearer. Add up function internal is clear. There. So the add up function internal is 3, right? So we know that it's still adding it. But then when we go to print out my sum, it says it's undefined. And that's because this function right here isn't sending the information back into the program anywhere. What we need to do is we need to use a special word. It's called return, right? And so then we can say return sum. And so what it's doing now is this function gets called, and then it's actually called here, right? And so then down here it says, okay, so A is 1 and B is 2. Then we've got our new variable sum, which is A plus B, right? And then we return this back into our main program. So now when we run this, right, what we'll see is 3. It's because we're returning this value back into our main program. So that's just to say that, like, you aren't going to return something all the time. You're only going to return something when you want it to do something and bring that information back into the main program, like addition, subtraction, or if you've got a couple objects that are talking to one another, a couple things that are talking to one another, and you're having a function deal with like the math or something, then it returns back true or false. That's when you want to use a return, right? For a lot of the things that we use in p5js, though, it doesn't need to return anything, right? So what I'm going to do is I'm going to back up here a little bit, and hopefully you all remember the bouncing ball example that we did with variables and conditionals from last week. If not, go back, watch that. It's like 7 minutes long. But what we can do is we can functionalize that, right? We can make it like a little, we can sort of abstract things a little bit. It also is going to help us tidy up our code a little. So I'm going to clean this up and get rid of all that, right? And so now what I'm going to do is I'm going to say, okay, remember we had let x and y, right? We'll just call it x pause and y pause, right? And so then these were these are the positions of of our ball, right? And so here we're going to say, x pause is, we'll say width divided by 2, and then y pause is height divided by 2. And so now we've got these values that are going to be right in the middle, right? So if we wanted to test that, ellipse, x pause, y pause, 100. Oh, whoops. There we go. Right in the center, right? So now if we wanted to, we could like sort of encapsulate some of this stuff, right? We could say function ball. Oop. Right? And ball could take 2 values, x and y, and we could say ellipse x, y, 100, right? If we go back and we look, nothing here, but as soon as we say ball, x pause, y pause, now all of a sudden we've got this, right? So it's one way that we can go and we can start to abstract things and make them a little bit clearer, right? All I've done right here is I've kind of like said, okay, anything that's called ball is always going to be 100 pixels wide, but I've moved this x pause and y pause thing out of I've moved this part out, right? And so now this becomes, the draw becomes a little bit clearer. I know exactly what it's like doing, right? Um, from here we could also do a little bit more where if we wanted to, if we wanted to, for example, abstract some of the other stuff that we would do with this, right? So, um, previously we were talking about doing things with, speed or position, right? And so we could say x speed, y speed, right? And then we can, in here, we could say like, didn't mean to cut it. We could say something like x speed equals random, 2, 5, right? And then one of these days I will figure out how to key command. And then y speed, random 2, 5, right? We'll make this -2, 5, right? Negative. Why not, right? And then, inside of here we would have typically something that would be like, x pause plus equal x speed and then we do the same thing for y, right? And doop, off it goes, all these directions. And then we could have, and we would have if statements, right? That would basically be saying like if it's, hitting a wall, right? So we would have something like if x pause greater than with or, remember that or, x pause is less than 0, equal to, less than equal to. And then we could say x pause equals negative x pause. Sorry, x speed, sorry. Boop. And then we can do the same thing here. So we can say y pause height, y pause 0, y speed, right? And then we've got our ball that just like now is doing its thing, bouncing along. And so like, fine, whatever. Like we've done this, we've seen this already. But now, our program's starting to like get extra stuff in here, right? So, what we can do is we could start to think about how we can, how we can sort of like abstract some of this, right? So we could have a function that's called something like, update x, right? Then another one, update y, right? And in these, the two things that you'd really want to know are the position and speed, right? So we can say x pause, x speed, and then y pause, y speed, right? And then here, down here, we can say function x, update x. And we'll do another one for function update y. And these will be pretty much identical. But what we'll do is we'll just copy and paste these out of here, right? So we go boop and boop. And so we can't refer to the these variables inside of here, right? It's going to kind of like screw things up. So what we want to do is we want to pass these in, and so we'll say, we'll mark it so we can say x pause lowercase that underscore, and then we'll say speed. In fact, we can just say pause and speed, and that'll be a little bit easier, right? So if pause is greater than width, then speed is negative speed, right? And then what we can do is we can say return speed. In fact, we only need one of these now that I think. Anyhow, we could just say update, but we'll say, x speed equals, and here we'll do the same thing for this, where we say y speed equals, right? And then in here, we'll just, actually what we'll do is that's the nice thing about this is like you can see this code now becomes really reusable, right? All we need to change here is height. And so now I save this and we go back and look at it so we can get a faster ball. And so now we'll see that we've got the same sort of functionality, bounce, off it goes, right? But our main program is now a little bit clearer, right? We're updating the location, we're drawing the ball, and then we're updating the speed as necessary. And so our draw becomes a little bit clearer to read. These functions then become something that we can copy and paste and put into other programs. So if you find that you've got something that you're doing over and over and over again, you can just take this, right? I could just take this update X and update Y, and I could drop these into any program that I want there where I'm updating like the speed of a ball, right? Which, oddly enough, I do a lot, right? This is just to show you that you can use functions in a bunch of different ways. They generate reusable code. They make your code a little bit clearer to read, and they just help abstract some things, right? These are going to become really important when we move on to, full-on object-oriented programming in the coming week. So play around with these. Make some sketches where you've got like functions that are doing multiple things, right? So maybe your ball actually has, as opposed to like updating like, maybe you've got like a bullseye inside of there, right? And so instead of having like all these ellipses inside of here, you can have, you can just sort of like do something like that, right? So again, like we've just made this change inside of here. It's reflected back inside of our main program. If we wanted to, we could also do the same sort of thing in here, where all of a sudden, if we wanted to add in like, another value, it becomes a simple sort of thing where we can say the radius of the ball that we're bouncing around, right? So this ball is like 100, right? So actually we would say here is 50. And then here we would accept another argument, rad, right? And then we could say position width minus rad. Now we've got something that'll bounce off of the sides, right? So again, it's just a way, and again, like our main program here still remains really nice and clean and readable, while all this sort of like junky stuff that we wrote is down here in this bottom code. So this is the power of functions, readable code, reusable code, allows you to make changes really quickly without affecting the main your main program. So give them a shot.